Welcome to all of you. Today we discuss on MCQ paper CC-11 semester 5 2020 BSc Mathematics Honors. Fifth semester 2020 Mathematics Honors paper CC-11. First question MCQ. Question 1A. In a game of bridge, the entire deck of 52 cards is dealt out to 4 people. The probability that one of the player receives all 13 spades is correct option is 2. Consider the case in which one exact player gets 13 spades of 52 cards. The probability would be 13 by 52 into 12 by 51 into 11 by 50 into into 2 by 41 into 1 by 40. Because at first 13 of 52 cards are spades, then 12 of the remaining 51 cards. So here 31 spades and out of 52. So when you draw first card, so you can draw a 31 spade and from 52 cards. And after first drawing, there are 12 spade and total number of cards is 51. So second drawing to get a spade is the probability 12 by 51, and third drawing 11 by 50 and so on, and last for 1 by 40. So this probability, this 13 by 52, 12 by 51 and 1 by 40 is the probability that one exact player get 13 spades. But the probability that one of 4 players receives all 13 spades is then 4 times of that probability. Here the question is that they deal the 4 people, the probability that one of 4 players, any one of 4 players receive all 13 spades. So there are 4 players. So first player get the first player gets 13 spades is the probability is this. Second player is same, third player is same, and fourth player is same. So adding all these, we get 4 into this, into this, into this. So this is equal to 4 into 13, 12, 2 into 1 is factorial 13, and 52, 51, 41 into 40 equal to factorial 52 by factorial 39. So we get 4 into 1 by factorial 52 by factorial 13 by factorial 39, and so 4 by 52 C13 is the correct answer. Next question, B, 1b, the probability mass function of random variable capital X is given by small pi equal to c lambda to the power I by factorial I, where I equal to 0, 1, 2, and c is a constant. Then probability of capital X equal to 2 as given by, correct option is 3, lambda square e to the power minus lambda by 2. Here we know for probability mass function small pi is summation from I is equal to minus infinity to infinity, pi equal to 1. Here range for I equal to starts from 0, so I equal to 0 to infinity, summation over mass function, probability mass function pi equal to 1. So value of pi is c is constant independent of I, so c is summation I equal to 0 to infinity lambda to the power I by I factorial is equal to 1, and hence c into e to the power lambda equal to 1, because e to the power x equal to summation I equal to 0 to infinity x to the power I by factorial I. So we can replace this infinite series by e to the power lambda, hence the constant c equal to e to the power minus lambda. Hence the probability mass function small pi equal to e to the power minus lambda, lambda to the power I by factorial I. Hence the probability of the event capital X equal to 2 equal to the small p 2, that is equal to e to the power minus lambda, lambda square by factorial 2. Next, 1c. Let capital X denote a random variable which takes any of the values -1, 0, and 1 with respective probabilities. Probability x equal to -1 equal to 0.2, probability x equal to 0 equal to 0.5, probability x equal to 1 equal to 0.3. Then the expectation e of x square equals option, correct option is 1, 0.5. Here we know the rth raw moment, that is equal to expectation capital X to the power r moment about the origin, rth moment about the origin. This equal to summation I equal to 1 to infinity small xi to the power r probability of capital X is equal to xi. This is the definition of the rth raw moment. So here r equal to 2. So expectation of capital X square equal to, here xi is the -1. First xi is -1. Say x1 equal to -1, x2 equal to 0, and x3 equal to 1. So -1 square and probability of capital X equal to -1. 0 square is spectrum 0 square into probability of x equal to 0, and 1 square third spectrum 1, this is the 1 square into probability of capital X equal to 1. Hence put all these probabilities 1 into 0.2 this equal to 0, and 0 into 1 into 0.3 this equal to 0.5 is the correct answer. Question 1D. The value of k for which fxy equal to k into bracket open 1 minus x square minus y square bracket close, where 0 less than x square plus y square less than 1, and fxy equal to 0 or otherwise. Each probability density function of a two-dimensional random variable xy is given by, the correct option is 3, 2 by 5. Now we know double integration both from minus infinity to infinity ranges from x equal to minus infinity to infinity, and y ranges from minus infinity to infinity. Fxy dx dy equal to 0 for continuous distribution. This fxy is the probability density function, and so with the value of this value of fxy equal to this k into bracket open 1 minus x square into y square. So put this k into integration, double integration over the region R, 1 minus x square minus y square dx dy equal to 1. Here R is the circular region. This is given by the sets xy, order pair xy, such that 0 less than x square plus y square less than equal to 1, less than 1. So this is the circular region, and this y equal to minus root over 1 minus x square to y equal to root over 1 minus x square. Now we transform this Cartesian coordinate to polar coordinates by putting x equal to r cos theta and y equal to r sin theta. So the Jacobian J, that is del xy by del r theta, that is equal to del x del r, del y del r, and del x del theta, del y del theta, this is determined. So we get cos theta sin theta minus r sin theta, r cos theta, and hence we get Jacobian J equal to r. And here r equal to root over of x square plus y square, theta equal to tan inverse y by x. Hence 1 becomes this 1 k into double integration over r, and this becomes k into double integration this 1 minus x square, that is 1 minus y square, that is 1 minus r square into Jacobian this r into dr d theta equal to 1. Here we change the limit because theta runs from 0 to 2 pi, so theta is the angle, theta is the angle, and 0 to 2 pi, so this angle is theta, this angle is theta, and 0 this angle x-axis, and when 2 pi theta is again back to x-axis in anticlockwise direction, rotation of anticlockwise direction, and r from 0 to 1 because the circle of radius 1, radius 1, so range theta 0 equal to 2 pi to this, and this first we d theta is theta, so theta 2 pi, so 2 pi k r equal to 0 to 1 minus r square r into dr equal to 1. So after integrating and definite integral from r equal to 0 to 1 and this equal to 1, and after simplification we get k equal to 2 pi. Next, question 1e, the moment generating function of binomial distribution with parameters n and p is given by, the correct option is 3, q plus p to the power t whole to the power n. This is the moment generating function of binomial x np variate. Here, moment generating function mtx of binomial x np variate is given by mtx equal to summation k equal to 0 to n e to the power tk n ck p to the power k 1 minus p to the power n minus k. And this is the definition of moment generating function of binomial x np, this. And this summation nck this p e to the power t whole to the power k 1 minus p to the power n minus k, and this equal to this 1 minus p equal to a and p to the power t equal to b, say, then a plus b whole to the power n. So this 1 minus p equal to q, so p to the power t plus q whole to the power n. Because q is the probability of the failure, p is equal to 1 minus p is the probability of success. So we know from this theorem formula, a plus b whole to the power n equal to summation k equal to 0 to n ck a to the power n minus k b to the power k. We use this formula from this summation to this, get this. Next, question 1f. Suppose capital Xi runs from 1 to n are independently and identically distributed with mean mu and variance sigma square. And let capital S square is equal to 1 by n minus 1 summation I equal to 1 to n capital Xi minus x bar whole square, then E of S square equals, the correct option is 1 sigma square. Here mu is the population mean and sigma square is the population variance, and x capital X bar is the sample mean here. Here first we calculate the summation. We omit here the summation range from I equal to 1 to n. So summation means summation I equal to 1 to n. Summation capital Xi minus x bar whole square. This is equal to summation bracket start Xi minus m minus x bar minus m. Here we use m in place of mu. You can use mu for the population mean. So this whole square, after simplification, you get this 2 into x bar minus m independent of I. So out of summation from this 2 into a minus b whole square, a square minus twice ab plus b square. And this is the summation, there are n terms, so n into a capital X bar minus m whole square. And now the summation xi minus m, that is equals to n into summation x bar minus n. So we put this 2n into capital X bar minus m whole square. And so after simplification, we get summation xi minus m whole square minus n into x bar minus m whole square. Let's call it 1. Now, expectation of capital S square is equal to 1 by n minus 1 and summation expectation of xi minus x bar whole square, because capital S square is equal to 1 by n minus 1, this constant, and this summation is this. So this 1 by n minus 1 is out of constant, out of summation, and after simplification from 1, we put this result 1 by n minus 1 in the summation summation expectation of e of capital Xi minus m whole square, and n into 1 by n minus 1 and expectation capital X minus m whole square. Now we know this equals to variance of capital Xi and n by n minus 1, and this is the variance of capital X bar. And this variance of Xi, this also equals to variance of X, because the all capital X1, capital X2, capital Xn are all have the distribution same as capital X, and variance of X bar. So we can replace Xi by X. So this variance of X bar equal to sigma square by n, because variance of X bar equal to variance of 1 by n to summation Xi. So so 1 by n square summation of variance of Xi, and Xi is the same distribution with X, so put X here, X. So this variance of X, summation variance of X equal to n into sigma square, So n into sigma square, variance of X equal to sigma square. So this summation is I is equal to 1 to n, so n into sigma square, so sigma square by n. So we get variance of summation X equal to n into sigma square, and after simplification we get this equal to sigma square. Question 1G. Two random variables, capital X, capital Y, have the least square regression lines with equations 3x plus 2y minus 26 equal to 0 and 6x plus y minus 31 equal to 0. Then the correlation coefficients between them is, the correct option is 3 minus half. First, we solve these two equations, straight lines of this, and after solving, we get x equal to 4 and y equal to 7. So these two straight lines meet at the point 4, 7. So mx equal to 4, my equal to 7. This is the mean for x equal to 4 and mean for y equal to 7. Now, if one be the regression line of y on x, and consider equation 2 is the regression line of x on y, then from 1 we get y equal to 26 minus 3x by 2, or y minus 7, because is y minus my here 7, so y minus 7 equal to 13, because 26 by 2 13 minus 3x by 2 minus 7. So after simplification, take common minus 3 by 2. So we get y minus my equal to byx bracket open x minus mx. This is the regression line of y on x. And from the second equation, x equal to, because we consider equation 2 is the regression line of x on y. So x equal to this 31 minus y by 6, and x minus mx equal to 4. So x minus mx equal to 31 by 6 minus y by 6 minus 4. And this after simplification, take common 1 by 6 equal to this. So this equation x minus mx equal to bxy bracket open y minus my. This is the regression line of x on y. So here byx equal to minus 3 by 2 and bxy equal to minus 1 by 6. Now we know the correlation coefficient rho square equal to byx into bxy. So this into this, so we get 1 by 4. So rho equal to plus minus half. Now byx is negative, so obviously the sign of rho must be negative, because we know this is the y minus my by sigma y equal to rho into x minus mx by sigma x. This is the regression line of y on x. So we can write y equal to my equal to byx into x minus mx. This is the regression line of y on x, where byx equal to rho into sigma y by sigma s. Sigma y is the uh, variance of standard deviation of y, and sigma is the standard deviation of x. So this byx, byx is the slope of the line of the regression line of y on x. This is the regression coefficients of y on x. And similarly, we can get from the regression line of x on y, x minus mx equal to bxy bracket y minus my. And the sign of rho, correlation coefficient, is same as the sign of byx or bxy. Next question 1H. Let alpha be a population parameter which is estimated with two statistics, capital A and capital B, with a probability of capital A less than alpha less than B equal to beta. Then the confidence coefficient for the interval estimate of alpha with A and B is given by first option beta, 1 beta. Here actually we apply here the definition of confidence interval. If for any epsilon with 0 less than epsilon less than 1, if it is possible to choose such statistics, a small a equal to f1 is the sample of size n, x1 x2 xn, and b is statistic f2 is a function of f2 x1 x2 xn, and such that probability of a less than theta less than b equal to 1 minus epsilon. For all theta, this belongs to this belongs to capital theta, where capital A is the corresponding random variable of the small a, that is f1 capital X1 capital X2 capital Xn, and capital B equal to the function f2 capital X1 capital X2 capital Xn are the random variables corresponding to the statistics a, small a, and small b. Then the open interval AB is known as the confidence interval for the parameter theta, with the confidence coefficient 1 minus epsilon. So if P probability of A less than theta less than B equal to 1 minus epsilon, then the confidence coefficient is 1 minus epsilon. So in this question, the probability of A less than alpha less than beta equal to beta. So confidence coefficient is the beta. Question 1I, let capital W be the critical region for the test of a hypothesis H0 against an alternative hypothesis H1. If X represents a sample of size small n drawn from the population, then probability of X belongs to W bar such that H1 is true, is the correct option is 2, probability of type 2 error. Actually, here this is the definition of probability of type 2 error. The null hypothesis H0 is false. That is, H1 alternative hypothesis H1 is true, and but the random sample X with sample size n, small n, does not belongs to the W, capital W. W is the critical region of the test. That is, random sample X belongs to the W bar, and when H0 is accepted. When H0 is accepted, H0 false, but H0 is accepted. So there is an error. And this type of error is called type 2 error. So probability of type 2 error is the probability of random sample X belongs to out of the critical region W bar, such that H1 is true. This is the definition of probability of type 2 error. Next, question 1J. Which of the following distribution is used to test the equality of standard deviation of two normal populations? Correct option is 4, F distribution. Because an F test is used to test if the standard deviations of two normal populations are equal. The statistic F is given by F equal to N1 capital S1 square by N1 minus 1 whole divided by N2 capital S2 square by N2 minus 1. This is the statistic F. Has F distribution with the parameters N1 minus 1, N2 minus 1. N1 and N2 are the size of the independent random sample corresponding to two normal populations with standard deviation sigma 1 and sigma 2. And capital S1 and capital S2 be the respective sample standard deviations. And we use this F statistic to test the null hypothesis H0 when sigma 1 equal to sigma 2 against the alternative hypothesis H1 such that sigma 1 not equal to sigma 2. We use the above F statistic, and for this case we use the two-tailed test for F statistics. So this completes the MCQ of 2020 BSc Honors Mathematics. Thank you.